So, hi, once again, welcome. Let us solve this problem and identify first. So, you can see the plate here, and this plate is subjected to multiple forces, and the coordinate system is also shown here x, y, z. It means what? Forces in 3D, or it is also known as space. Now, so let us read the statement. Five vertical forces are acting on a horizontal plane. Okay, so this is what? This is the plate. This is plate. Plate. As shown in figure, find the resultant of the forces and point of application with respect to origin. So let us solve it. Solution, and what we have to find out? We have to find out. We have to find out first the resultant of the forces, means r vector, and secondly the point of application with respect to origin. These are, we have to find out with, means the coordinates, or you can say the point of application, or you can say the point of application, point of application. Okay, application of which force? So which force? Which force? So obviously resultant. Okay, so let us move forward. So how to get the point of application? Let us uh, do it from the reverse direction. Okay, we should know what is our objective. Okay, so how to find out the point of application? Point of application. For that, to get this, remember we need to apply Varignon's theorem. Varignon's theorem. And what is this? So it is the summation of moment about O, and it's in vector, is equal to the moment of the resultant. So this is what? This is moment of the resultant, and this is what? Summation of moment. So it is what? Summation of the moments. Summation of the moments. Summation of moment of force about forces about origin. Okay, and let us deal then what is the MR. Okay, so how to get MR? To get this, what we have to do? Everything here we are taking with respect to origin and the moment of resultant. Okay, so that's why moment of resultant means the summation of means moment of resultant means this R, and which will be multiplied by R O P. We can see this O is origin in the figure, and OP means there is some point where our resultant may lie. So it is obvious it will lie in X and Z plane. So suppose it is lying here somewhere. Okay, then we have to find out its coordinates about from X, Y, Z axis. Okay, so for that, so this is resultant and a multiplied cross. So this is the cross product, and ROP. Then ROP is what? So it is position vector. Position vector. Okay, and then we should know about the coordinates of P, position vector. Okay, so here P is there, and what about the coordinates of O? This is origin coordinates. Coordinates, it is 0 0 0. Okay, and what about P? So let us and this plate is in the X and a Z plane, so that's why it will have some value of X, but Y 0 and Z. So it is the position vector. Okay, now what is R? So R is the resultant of the forces. R vector is the resultant force vector. And it is equal to how many forces are there? So 5 forces are there: F1, F2, F3 plus F4 plus F5 in vector form. Okay, then what is Fi? So Fi, we need to come back to the figure. So this is Fi. Fi is what? 3 kilonewton. F2 is what? 5 kilonewton. F3, it is 6 kilonewton acting downwards. Okay, and the vertical direction is what? It is parallel to the y-axis. It is parallel to this y-axis. And what about F4? So this one F4, and it is acting in upward direction. What about F5? So it is 7 kilonewton and acting in downward directions. So from here we can write, means we need to know the force vectors actually. So what will be force vector? F1 in vector form, and you can see it is acting downwards and parallel to y-axis. So acting downwards, that's why minus, and parallel to j. What about F2 is equal to, F2 is also acting downward 5, and all the forces are acting vertically, either downwards or upwards. So let us F3, this one. So where is F3? F3 is 6 kilonewton, and 6 with minus sign, J, and F4. So F4 is what? F4, it is with positive sign. Why? It is acting in upward direction, that's why. And a positive sign, no need to write here. So it is 2 and J. What about F5? All in vector form, F5. So this 7 kilonewton minus 7J. Okay. So from here we can get the resultant, means it is the sum of the forces. So it is F1, F2, F3, F4 plus F5 in vector form. This is just F1 के ऊपर हमने बार या कैप लगा सकते हैं. ओके, सो F1 is minus 3J, F2 is minus 5J, F3 6J, F4 2J, but it is with the plus sign, and F5 is equal to 7J. Okay, so what we get? Is equal to, we get 19J. Okay, so coming to here, what we get, this is equal to, means all 19J. And coming back to here, because this is required, our resultant is required to get the moment of the resultant, this one. Okay, so how to, once again, then we are going to show MR is equal to ROP multiplied by R, and ROP is equal to what? So ROP is equal to मीन्स क्या हो जाएगा, OP here, OP, so x minus 0 I and plus 0 minus 0 J plus Z minus 0 K. Okay, so what we get, we get x I and z k, xi cap, z cap, and it is multiplied, means there is a cross product, and r is equal to what? It is minus 19j. Okay, so this can be shown in the matrix form. So I, j, k, and what is this? We are going to multiply, okay, this x and z. Okay, so x we have to write, and there is no y coordinate, that's why 0, and it is z. And what about the resultant? So it is in j direction, means y axis. So that's why x axis will be 0, in y 19, z is equal to also 0. Okay, because the resultant lies in only y axis. Okay, from here what we get? We get mr vector is equal to 19 z I cap minus 19x k cap. This we get. This is our the resultant of moment in vector form. Okay, now coming back to, this is for what? To get the means point of the applications. So summation of moment is equal to mr, means moment of the resultant. So what about moment of resultant? This now we have, but what about, do we have this one too? So our answer is no, we don't have. So now let us find out this. So our purpose is to get the moment vector. Okay, and this is what, once again, this is what a resultant moment. Okay, resultant moment. So what we have to do here? We have to sum up all the moments, m2, m3, m4, m5, okay, and all in vector form. Now how to get m1? And m1 is what? These are what? These are what? So these are the moment vectors. Okay, so how to get this? Suppose we have to get m1. Okay, and here everything is about the origin. Okay, so m1 is equal to then r1 and then the f1, it is cross product. Okay, similarly m2 is equal to r2, f2 here, m3 is equal to r3 and f3 here, m4 is equal to r4 and f4 here, M5 is equal to R5 and the cross product of F5. So we know about the forces, force vectors. We know all the force vectors. Okay, this already we have found out. You can see here these are the force vectors. So now what we have to find out? We have to find out the position vectors here. So let us find out the position vectors R1, R2. Okay, so we need to take help of the figure. Here, so this also we can copy. Let us put there, paste there. Oh, something else is coming. Yeah, it's okay. Let us not focus on these things. Actually, I am learning this software, so little bit. This platform, I'm not means I'm new. So let us remove this, remove this, remove this, remove this. Okay. So what we have to find out? We have to find out this R1 with respect to origin. Okay. Let us R1 vector we have to find out with respect to origin. Okay. So this is our origin, and F1 is acting. It is means at the F1 the line of action is at O. That's why what will be R1 will be 0. And what about RO? Okay, sorry, R2. R2 will be what? So it will be R2 here. R2 is equal to O, from O to A. OA. Okay, and this is equal to what? This is equal to, you can see here only the dimensions. You can see here in parallel to this, it is here 4 plus 2. This 4 and 2 parallel to this means this distance we have to find out. This one O to A, and parallel to this one it is. Okay, so it is 4 plus 2. It is 4 plus 2, and in it is parallel to x. Okay, that's why I. Now what about R3? So here we're talking about here f3, so f3 r3 vector, and it will be from here o to b, this o to b, ob, and it will be what to reach b. Okay, what we have to do, we need to move along the x direction. Okay, then the z direction parallel to z, this one. So क्या करना पड़ेगा हमें for this? Firstly we need to move in x direction, and it is how much? So it is 6i, and then z direction. Okay, so and z direction how much? So this one 5 meter. That's why here 6i plus 5z. Okay, what about r4? So here r4, let us find r4, this one, and r4 will be what? So OC, it will be OC from here to here. OC is equal to what? To reach OC. So how to reach OC? So firstly what we have to do, the 4i here means parallel to this OC. Firstly we have to go to parallel to this, or you can say to reach there, this one in z direction, and it is of 5. So z direction 5 z. Okay, and from here from D to C, so it is of 4i. Okay, what about r5? So r5 is equal to what? So OD, we have to get OD. Okay, so OD, and it is in the z direction. This one along z, OD, and then what will be R5 is equal to this one. We have to reach here OD. So how to reach? So from here you can see it is of 5 meter. Okay, so that's why what will be here 5 and Z cap, here also cap. Okay, so in this way now we have values of position vectors. Okay, so our purpose is what? To get, our purpose is to know about what is our M1 in vector form, and it is R1 multiplied by means cross product F1, and R1 already we have from here. R1 is equal to 0. So this will be what? I, J, K, R1 0 0 0, and F1 is what? So F1 we can see from here, F1 is minus 3j. F1 is minus 3j. ठीक है, minus 3j, so this will be 0 and this will be minus 3 and it will be 0. So in this way what we get? We get here m1 is equal to 0. Similarly, m2 we get minus 30k, m3 we get 30i minus 36k, and m4 we get m4 we get minus 10i plus 8k. What about m5? m5 we get 35i. Okay, so these are our what? These are the moment vectors. So finally what we have to get? We have to get the summation of moment about O. So it is m1, m2, m3, m4 plus m5, all in vector form. So what we get by adding all the moment vectors? We get 55i minus 58k, and it is in kilonewton. Don't forget to write the unit. Okay, now we have to applying Verrignon's theorem, applying Verrignon's theorem. So it is equal to summation of MO is equal to the moment of the resultant, and is equal to what we get from here, 55i minus 58k is equal to MR. And what is the MR here? Let us see what we get. MR, moment of the resultant, this is MR. Let us, can we copy it? It is 19zi minus 19xk. So here we are going to equate it, 19zi minus 19xk. Okay, so what we have to do here? We have to equating the coefficients we have what, like this, comparing with this. So 55 is equal to 19z. Okay, so here z is equal to what we get, 2.89 meter, and comparing this k coefficient, so it is 58 is equal to minus 19x. So from here we can get x is equal to we get, and both are minus, actually this is also minus, sorry, so it is 3.05. So finally our answer is what? The resultant, our answer, resultant, and its point of application with respect to origin. So here R we have, R vector we have 19 J in kilonewton. Okay, acts 8 point P, and it is 3.05, this 0, then comma, 2.89 meter. Okay, so this is your final answer, and let us summarize it. So where our resultant will lie? So R is 19J along the Z direction, okay, and minus. So minus means downward, it is acting downward. And what about from x distance? X is equal to, this is the x, and it is 6 meter. So 3.05, x is equal to 3.05. So somewhere here about, okay. And what about z? So z is equal to 2.89. okay, so z, this is the z direction, this one z direction, so parallel to this, and it is of 5 meter. Okay, so somewhere here will lie the resultant, like this one. Okay, so from here, so here, actually parallel to this, we have to measure from here, origin, ये हो गया, and ये आपका एक से यहाँ से हो गया, एंड जेड डायरेक्शन आपका इतना मूव करने के बाद मीन्स here somewhere here. This is the resultant. So what we did, and what was my approach in this question? What we wanted to know about first the resultant, okay, then the point of application of that resultant. So that we get from the Verigna's theorem, we should know. Okay, and what is the Verigna's theorem? It is summation of moment about O. Here everything we are going to find about origin is equal to moment of resultant. Okay, and then what is this moment of resultant? हम इसके पीछे भागे, ठीक है. So moment of resultant is what? It is position ROP multiplied by the resultant. Then what is resultant? ठीक है. And before that, position vector. So position vector are OP, and P is some coordinate, suppose. Okay, that we don't know, we assuming. And P is equal to x 0 z, because it lies in x z plane. Okay. Okay, so this is position vector. And then resultant means all the forces we have to sum up. Okay, and how to know, like f1 is equal to what? So it is in figure it is clear that it is given, like f1, this is f1, and this axis is also the, this is the y-axis. Okay, so f1, and it is acting downwards, that's why f1, suppose what we have the value c j. In this way all the forces we found out. Then the moment of resultant, finally after getting this, the position vector, after getting the resultant, we multiplied, means there is a cross product, and through the this matrix we get this. Then coming back to now, what is moment of resultant, this we know. So what is required? This is required. Okay, so अब इसके पीछे भागेंगे. ठीक है. So this is equal to moment of summation of moment about O. So ये क्या है? It is सभी moments वेक्टर का सम अप है. ठीक है. और उसके बाद सम अप है, तो then what is m1, how to get it? ठीक है. So it is again multiplied by the position vector. Okay, and the फोर्स लाइक f1. ठीक है. तो मतलब क्या है कि f1 ओरिजिन से कहाँ पर है. ठीक है. सो कहाँ पर है, दैट वी नो थ्रू द पोजिशन वेक्टर. ओके, एंड आफ्टर डूइंग दिस, फाइनली we get the summation of moment about O. So at this point we have both summation of MO and moment about moment of the resultant. ठीक है. This we have, this we have. So what is the next? We have to just equate the coefficients. Okay. So after this, now we came to know about the coordinates of P, x 0 and z. ठीक है. सो R कहाँ पे लाई कर रहा है? इन द एक्स वाई प्लेन. ठीक है. सो ये कैसा पता चलेगा? बाय फाइंडिंग x and z. So by equating the coefficients, now we found out. ठीक है. So in this way we have done this. Thank you very much.